Here we'll look at what the graph of an inverse function looks like. And there's an example here. There's some explanation that I kept because I think it's important. So if you have the point AB on your original graph F, okay, then the opposite of that, which would be B and then A, so just flipping them around, would appear on the inverse, right? Because the inverse is just switching the two, the opposite. And what that means is the graph of the inverse, so the graph of f to the negative 1, is a reflection of the graph of the original on the line or in the line y equals x. So it's not a reflection on the x-axis or the y-axis or the origin. It's a reflection of this line y equals x. So whenever you're asked to graph, you'll always want to graph this line because that is where the reflection should occur. So that's where you should see it. And you can see that for this one, your original function, f of x, is this kind of shaded line here. And then your inverse function is the exact opposite based off of that blue line that's in the middle. So let's do one of these examples together. So verifying inverse functions graphically. Sketch the graphs of the inverse function of f of x. So let's see. Here's our original function. Here's our inverse function. Graph it on the same rectangular coordinate system and show that the graphs are reflections of each other in the line y equals x. So really there's three things we need to graph. We need to graph our original function, which I have shaded in gray. We need to graph the inverse, which is shaded in red. And we need to graph y equals x because that's our comparison line. So let's go ahead and graph that one first. I'm going to graph that one in blue. So if y equals x, that means the slope is 1 and the y-intercept, there's nothing there, so it's 0. So to graph that y equals x line, we do that in blue, we'd start at 0 and then we just do up 1 over 1. So this is the line that our two functions should be reflected across. So it's important that we graph it so we have that comparison to make so we can verify using our graph. Okay, so there's a line we're going to use to compare. Now let's go ahead and graph our two functions. So I'm going to do the original in black. So here our y-intercept is -3 and our slope is +2, so up 2 over 1. And it's okay if it crosses this blue line. It's normal. It can happen. Okay, so here's our first function. Here's our original function. And then if we graph the inverse, it should look like this, but reflected across that blue line. So let's see on this one, our y-intercept. If we look here, we get 1/2 times x plus 3. So I need to distribute this 1/2 to get my actual y-intercept. So this would be y equals 1/2 x. So there's our slope plus 1/2 times 3 is 3/2, which is 1.5. And so our y-intercept would be 1.5. So up 1.5. Okay. And then I'm going up 1 over 1 for my slope. So, oh, sorry, up 1 over 2 for my slope. So up 1 over 2, up 1 over 2. Make sure you're just careful with that, with the halves. Go up 1 over 2, and then down 1, -2. And there's our inverse function. So notice how the blue line is the reflection point for what we have in black and in red. So if I look at what's in blue, if I highlight that, the black line is then reflected across the blue. So it's like reflected a diagonal. If you held your device kind of at an angle so the blue line looked like it was straight, then maybe you'll see that reflection a little bit more if it doesn't quite make sense. But that's what that would look like on a graph. Another thing we can use to graph to just tell if we have an inverse, if an inverse if an inverse exists is called the horizontal line test. So it's kind of like, it's the opposite of the vertical line. Vertical line test tells us if a function exists. Horizontal line tests tell us if its inverse would exist. And if there is an inverse, it's called one-to-one. It is a one-to-one function, one input, one output in both directions. So for example, there's two graphs that we have a picture of here. The first one is a parabola. We're really familiar with those. And we know parabolas are functions because they pass the vertical line test. If I drew lines straight up and down, it only crosses once. So yes, this is a function. Okay, that is correct. However, to decide if there is an inverse function, does it have an inverse, we would look going across. We would go horizontally. And here you can see with the pink line that's drawn, it crosses at 2 points. So yes, it's a function, but there's no inverse because it's not what we call one-to-one. So if you're ever asked if it's one-to-one, look at this. It's not one-to-one. And what that means is if you have your original ordered pairs and then you flip-flop them, that's not a function because horizontally here, this is not a function. So one-to-one means that it's a function and it has an inverse. Here's an example that is a function and it has an inverse. So we can check our function going straight up and down, right? There's no points that cross more than once going straight up and down. And going side to side, there's no points where the graph would cross more than once. So yes, this is a function because of the vertical line test in blue. And then yes, it has an inverse and is one-to-one. Because it passes the horizontal line test as well. So one-to-one, if you want to think about it graphically and kind of simple, one-to-one passes the vertical line test that only crosses at 1 point, and it crosses the horizontal line test and only crosses at 1 point. So there's your definition of one-to-one. And then here's a visual of it with some ordered pairs. So here we have just the table of values for the parent function of a parabola, just f of x equals x squared. So if you do -2 squared, you get 4. -1 squared is 1, and so on. Well, here's what the graph looks like if you do the inverse. If you flip-flop them, right? So instead of -2 and then 4, we wrote 4 and then -2. And if you do that, you notice that the 4 has 2 outputs. But we know for a function, each input can only have 1 output. So because when you flip-flop the 2 and you change the x and the y values for the inverse, because you have where this 4 has 2 different outputs, so 4 has 2 outputs, that means that it does not have an inverse. Okay, so that's one way to check it. It's not one-to-one. It's not a function when you flip-flop the x and y values. And then notice, like we talked about as well, it does not pass the horizontal line test for the parabola. If you draw that horizontal line, it's going to cross twice. So that tells you as well it's not one-to-one and it does not have an inverse. Here's another example of a graph that does have an inverse. So if you have this x to the third power shifted down 1 unit, so -1, if you draw any horizontal line, it's going to cross at 1 point. Only 1 point, anywhere on there, never twice. So this function does have an inverse. And this is one where we would want to use our algebra to create our inverse because it's got the cubed function and subtraction. So we want to make sure we're a little bit more exact by using algebra, and we'll look at that next.